Good afternoon, all of you. In today's lecture, we are going to discuss next article, that is fugacity and activity concepts. All of you know that ideal solution and ideal gas. Ideal solution is nothing but the solution which obeys the Raoult's law over the whole range of concentration and at all temperature. Ideal solution is nothing but the solution which obeys the Raoult's law over the whole range of concentration and at all temperature. Ideal gas is nothing but the gas which obeys the gas laws at all temperature and pressure. But when the solution is at low concentration and the real gases are at high pressure, then there is deviation from the ideal behavior. And that's why this deviation we are going to consider. Okay. And we see here, if we apply this relation, delta G is equal to, if we apply the relation that is delta G means change in free energy, is equal to integration of nRT divided by P within the limits P1 to P2, nRT dP divided by P is equal to nRT log of P2 divided by P1. So we can apply this relation to the solution which at low concentration and the real gas is at high pressure. Then there is deviation should be takes place, and because of this deviation, the gases which are at high pressures, they are not obeys the ideal gas equation, and because of that V is not equal to nRT divided by P. If this equation is not satisfied or not obeyed by the gases which are at high pressure and the solution which at low concentration, then this equation is not applicable. Okay, and because of that, the scientist Lewis was introduced new thermodynamic function, that is the fugacity and the activity concepts. Now I am going to explain to you the first term, that is the fugacity, and this fugacity is denoted by the letter F. So this is a new thermodynamic function, that is fugacity, and it is denoted by the letter F. So for this study of fugacity, we can consider the system. We have to consider the system in which the beaker containing the water liquid which is kept at constant temperature. Then we'll observe that the molecule which are present in the surface of the liquid have a tendency to escape from that flash, and they are get converted into the vapor. So here we see the water molecule first get converted into the vapor. So this process is known as the evaporation. When the liquid get converted into the vapor, then it is known as the evaporation process. Okay. Now we see here the molecule which are the vapor molecules which are present in the free space as above this water liquid, they have also tendency to come back to its original place, and this vapor molecule get converted into the liquid. So this process is known as condensation. All of you. So here the rate of initially the rate of evaporation is low, the rate of evaporation is very high, and the rate of condensation is low. but after some time the rate of evaporation is equal to the rate of condensation, and both the state of the substance water is at equilibrium state. Means that is liquid is in equilibrium with vapor. So here what I am going to say here, the water molecules which is present in liquid state, they should have a tendency to escape from its original state, that is the water liquid, and undergoes the evaporation in which they are get converted into the vapor. So means water molecule have tendency to escape from its original state, that is water liquid, and they will convert it into the water vapor. Correct? And during the condensation process, vapor molecule also have tendency to escape from its state, means vapor state, and undergoes the condensation process, and this vapor molecule get converted into the liquid. So from this example, we can conclude that every substance have a tendency to escape from its state, and this tendency of the substance is termed as the fugacity, and it is denoted by the letter F. So fugacity is defined as any one substance have a tendency to escape from its state. Every one substance escapes from its state, and it is quite general, and it is termed as the fugacity, and it is denoted by the letter F. And mathematically this fugacity is given by dG is equal to nRT derivative of log of F. Here dG means infinitesimal change in Gibbs free energy, N number of moles of the gas, R gas constant, T absolute temperature, and here the derivative of log of F, that is the fugacity. F means the fugacity. So fugacity is mathematically related as with free energy according to this equation. If we take the integration of this equation, on integrating integration of dG nRT integration of derivative of log of F, and that is equal to G nRT, and integration derivative of log of F means log of F plus C. In this equation, C is constant of integration, and when F is equal to 1 means fugacity of the substance is equal to 1, means substance is present in standard state. At that time the free energy is equal to standard free energy. So if you substitute the value, F is equal to 1 here, means log 1, and G is equal to G0. So this equation becomes G is equal to 0, and if you substitute the F, log 1 is 0, and 0 multiplied by nRT is equal to 0. So G0 is equal to C. So then this equation becomes G is equal to G0 plus nRT log of F. So G is standard, G0 is free energy, G0 is standard free energy, nRT F means fugacity. Okay, so this is the on integration. This equation can be changed into this form, and if you integrate this equation within the limits, then integration of 1 with respect to dG from G1 to G2 is equal to nRT integration of derivative of log of F within the limits F1 to F2. Again integration of 1 with respect to G is equal to G, and upper limit is G2, lower limit is G1. We can substitute this limit. So G2 minus G1 is equal to delta G, and that is equal to nRT. Here again the integration of D derivative of log of F, log of F, and after substituting lower limit and upper limit, here this equation becomes log of F2 divided by F1. Okay, so this is the final equation. All of clear? So this is about the fugacity. So fugacity is nothing but, that is, any one substance have tendency to escape from its state, and it is quite general, and it is denoted, and this escaping tendency of any one substance from that state is known as the fugacity, and state is denoted by the letter F. And we have to remember that fugacity has the dimension of pressure. So in our examination, the objective question asked like this: the fugacity has the dimension of dash dash. So fugacity has the dimension of pressure. This is the answer. Okay. Now we see here. Now we are going to discuss the last point, activity. That is activity, and it is denoted by the letter A. Now we see here, F is nothing but fugacity of the substance in a given state, and F0 is nothing but fugacity of the substance when it is present in standard state. So we see here, F means fugacity of the substance. Fugacity of the substance in a given state, whatever it may be state. And when the same substance is present in standard state, then fugacity of that substance is denoted by the letter F0. So the activity is equal to F divided by F0. So this ratio is known as activity. So activity of the substance is nothing but the ratio of, it is the ratio of fugacity of the substance in a given state to the fugacity of the substance in a standard state. So this is the definition. Activity is nothing but the ratio of fugacity of the substance in a given state to the fugacity of the substance in a standard state. Activity is also given by one more equation. Activity is equal to m into gamma. So whereas A means activity, m means molality. This is the one of the unit of concentration. Sorry, here activity we can consider the concentration. Activity is equal to C multiplied by gamma, whereas C means concentration and gamma means activity coefficient. So activity is also defined as the product of concentration and activity coefficient. So this is the final equation. So these are the two equations about the activity. तर पहा की ideal solution and ideal gas. Ideal solution म्हणजे काय? The solution which can be obeys the Raoult's law over the whole range of concentration. And ideal gas म्हणजे काय? The solution which obeys the gases laws at all the values of pressure and temperature. परंतु काय होतं पहा की सोल्युशन लो कॉन्सन्ट्रेशन असेल आणि the gases जर हाय प्रेशरला असेल तर ह्या आयडियल बिहेवियर पासून डेव्हिएट होतात आणि हे डेव्हिएशन तुम्हाला विचारात घ्यावं लागतं. मग पहा हे जर इक्वेशन म्हणजे आपण लॉ ऑफ मास ऍक्शन डिराइव्ह करत असताना हे इक्वेशन आपण मिळवलेलं होतं आणि हे इक्वेशन ज्यावेळेला आपण गॅसला अप्लिकेबल केलं की जो गॅस हाय प्रेशरला असतो आणि सोल्युशन लो टेम्परेचरला असेल तर त्यावेळेला ते डेव्हिएशन झाल्यामुळं मग ते दोन्हीही म्हणजे सोल्युशन विच ॲट लो कॉन्सन्ट्रेशन आणि गॅसेस ॲट हाय प्रेशर हे इक्वेशन ओबे करत नाही म्हणजे आयडियल गॅस इक्वेशन म्हणजे हे इक्वेशन पुन्हा सॅटिस्फाय होणार नाही. म्हणून लुईस या सायंटिस्टनी नवीन थर्मोडायनामिक कन्सेप्ट ॲप्लिकेबल केला किंवा इंट्रोड्यूस केला तो म्हणजे फुगॅसिटी. काय फुगॅसिटी आणि इट इज डिनोटेड बाय द लेटर एफ. मग फुगॅसिटी म्हणजे काय? अतिशय सिंपल आहे. पण की तुम्ही वेपर प्रेशरचा कन्सेप्ट अभ्यासवेळी हे अभ्यासलेलं आहे की एखादं लिक्विड, आता आपण इथं वॉटर लिक्विड घेतलेलं आहे की लिक्विड घेतल्यानंतर त्याच्यातले मोलिक्यूल वेपरमध्ये पास होतात इव्हॅपोरेशनमुळे. म्हणजे सबस्टन्स एका स्टेटमधून दुसऱ्या स्टेटमध्ये जातो. आता इथं वेपर मोलिक्युल्स आहे तो मला याला इव्हॅपोरेशन म्हणतात, लिक्विड टू वेपर, आणि वेपर टू लिक्विड याला म्हणतात कंडेन्सेशन. म्हणजे वेपर टू म्हणजे कंडेन्सेशन. आणि काही वेळानंतर रेट ऑफ इव्हॅपोरेशन आणि रेट ऑफ कंडेन्सेशन इक्वल होतं आणि इक्विलिब्रियम स्टेट येते. मग एखादा सबस्टन्स एका स्टेटमधून दुसऱ्या स्टेटमध्ये जाणं ही जी प्रक्रिया आहे या प्रक्रियेलाच फुगॅसिटी असं म्हटलं जातं आणि इट इज डिनोटेड बाय द लेटर एफ. येते लक्षात? Any one substance have a tendency to escape from that its state is known as fugacity, and fugacity has the dimension of pressure. मग फ्री एनर्जी आणि फुगॅसिटी मधील हे रिलेशन आहे. मग इंटिग्रेट करा हे इक्वेशन मिळेल. मग फुगॅसिटी 1 म्हणजे सबस्टन्स स्टँडर्ड स्टेट मध्ये आहे असं म्हणा. मग G इज इक्वल टू G0 मग हे पुटअप करा हे मिळेल. पुन्हा हेच इक्वेशन जे इंटिग्रेट केलेलं आहे ते विदिन द लिमिट इंटिग्रेट करा मग हे इक्वेशन मिळेल. मग डेल्टा G इज इक्वल टू nRT log of F2 upon F1. F2 म्हणजे फुगॅसिटी ऑफ द सबस्टन्स व्हेन इट इज प्रेझेंट इन फायनल स्टेट and fugacity of the substance when it is present in initial state. F2 means fugacity ज्यावेळेला सबस्टन्स फायनल स्टेटमध्ये असतो आणि F1 म्हणजे फुगॅसिटी ऑफ द सबस्टन्स व्हेन इट इज प्रेझेंट इन स्टँडर्ड स्टेट. मग ऍक्टिव्हिटी म्हणजे काय की F/F0 इट इज द रेशो ऑफ फुगॅसिटी ऑफ द सबस्टन्स इन अ गिवन स्टेट टू दी फुगॅसिटी ऑफ द सबस्टन्स इन अ स्टँडर्ड स्टेट. आणि ऍक्टिव्हिटी इज इक्वल टू कॉन्सन्ट्रेशन मल्टिप्लाय बाय ऍक्टिव्हिटी कोएफिशिएंट. सो दिस इज अबाउट द फुगॅसिटी अँड ऍक्टिव्हिटी कन्सेप्ट. मग याच्यामध्ये तुम्हाला फुगॅसिटीची डेफिनेशन माहीत पाहिजे, हे इक्वेशन माहीत पाहिजे, त्याच्यानंतर ऍक्टिव्हिटीचं इक्वेशन माहीत पाहिजे आणि त्याच्यानंतर हे दुसरं इक्वेशन माहीत पाहिजे. ओके. अँड फुगॅसिटी हॅज द डायमेन्शन ऑफ प्रेशर. हा बऱ्याचदा क्वेश्चन ऑब्जेक्टिव्हला विचारते. ओके. I will continue in next lecture.